A particle of mass m oscillating along x-axis according to the equation x is equal to a sine omega t. The nature of the graph between momentum and displacement of the particle is. Here one particle is there, the mass is m, it is oscillating along the x-axis. And x-axis is oscillating according to the equation x is equal to a sine omega t. Then, what is the nature of the graph between the momentum and the displacement we need to find here? Okay, so we can write the momentum, that is equation, that is x is equal to, we can write it as given, that is a sine of omega t. Then, or we can write the same equation as x divided by a is equal to sine of omega t. I'm going to consider this as equation number 1. And the velocity, if I'm going to write the velocity, that is a v is equal to, differentiate the above equation, that is a dx by dt with respect to dt, that is a times omega into, that is we get the answer, if we are going to differentiate, we get the answer a omega cos of omega t. Then we can write this one as v divided by a omega is equal to cos of omega t. I'm going to write this as neighbors, this as equation number 2. Then squaring and adding 1 and 2, we get, square the terms and adding 1 and 2, we get x square divided by a omega a square plus v square divided by a square omega square is equal to sine square omega t plus cos square omega t. Sine square omega t plus cos square omega t is equal to 1. We know that value. That is x square divided by s square plus v square divided by a square omega square is equal to 1. If we get the value of 1, then we can take, it is this equation, it is the ellipse equation. Hence, the graph between the velocity and the displacement is an ellipse. The option C is our right answer.